Have you ever wished you had a crystal ball? Like to see the weather, 10 days out. Not just a vague idea, but a super accurate, detailed forecast for the whole globe.
Oh, yeah.
Well, get this. Thanks to machine learning, that's getting closer to reality.
It really is. It's really shaking things up, the world of weather forecasting. It's a fascinating shift.
We're diving into a paper today, straight from the journal Science, called Learning Skillful Medium-Range Global Weather Forecasting.
Oh, wow.
To understand how this new AI weather model, called GraphCast, actually works.
Yeah, this paper is really a landmark moment. I think it really shows how machine learning can be used to model complex systems like weather.
Okay, so before we get into GraphCast itself, let's quickly touch on how traditional weather forecasting works. Massive supercomputers, right? Crunching numbers.
Yeah.
Based on complex physics equations. That's called numerical weather prediction, or NWP.
Right.
And the European Center for Medium-Range Weather Forecasts, they go by ECMWF. They've kind of been a leader in this area with their powerful system.
Yeah, traditional NWP is really sophisticated, but it has limitations. It requires a lot of computing power, and it doesn't easily integrate historical data.
So that's where machine learning weather prediction comes in, or MLWP. What if we could use decades of weather data to train an AI model to learn from it?
Yeah.
And make predictions?
Right. That's the exciting potential of MLWP. I mean, with so much data available and the advancements in these algorithms, it's a really promising approach to forecasting, especially for these medium-range forecasts, like predicting the weather up to 10 days out.
Which brings us to GraphCast. One of the things that jumps out about it is its speed. It can create a global 10-day forecast, down to your neighborhood, basically.
Oh, wow.
In less time than it takes to grab a coffee. Less than a minute.
That's amazing.
Compared to the hours it takes traditional systems. That's a big deal, right?
That speed is critical, especially for those situations like severe weather events, when, every second counts.
So how does GraphCast pull this off? It uses a really, I think, a clever approach called graph neural networks.
Or GNNs.
Okay.
Think of it like connecting the dots on a global scale. So GraphCast is analyzing how weather data points across the globe relate to each other to understand how these patterns evolve.
And it's constantly updating and evolving its predictions as it gets new information.
Right. So this process, it gets repeated, right, to generate these forecasts that go out as far as 10 days. And it's all trained on this huge data set. 39 years of historical weather data.
Wow.
Using something called the ERA5 Reanalysis Archive from ECMWF. It's like giving GraphCast the ultimate weather textbook to study.
Right. That's a really important point. The quality of the training data is absolutely key for any machine learning model.
So the big question is, how does GraphCast measure up against the top dog? ECMWF's high-resolution forecast, which is known as HRES.
Right.
And the results? Well, they're pretty impressive.
They really are. The research shows GraphCast actually beats HRES on 90% of over 380 targets they looked at.
Wow, that's a serious accomplishment. Keep in mind, HRES has been the gold standard. So to see GraphCast surpass it really highlights how machine learning is changing the game.
And we're not just talking about general weather patterns here, right? We're talking about specific things like geopotential height, which, to be honest, I had to look up. It's basically a measure of the height of a pressure surface in the atmosphere.
Okay.
Which is super important for understanding large-scale weather patterns.
Right. What's interesting is GraphCast isn't just matching HRES, it's beating it in a lot of these cases.
Now, there is a bit of a trade-off, though. The study mentions that GraphCast can blur its predictions as you look further out in time, kind of like how a photograph loses its sharpness when you zoom in too much.
Right. That blurring happens because the model is optimized for overall accuracy rather than precision at those longer timescales. So it's a different approach from the traditional NWP.
But here's where it gets really interesting. Even though GraphCast wasn't specifically trained to predict extreme weather, it's surprisingly good at it. And that's a huge deal for safety and disaster preparedness.
It's almost as if it can see these subtle signals, the early warning signs in the data that lead up to those severe events.
Okay, so let's get specific. When it comes to predicting the paths of hurricanes, GraphCast is significantly better than HRES.
And think about what that means for coastal communities, right? They could have more time to prepare, evacuate, potentially saving lives.
Yeah, that extra lead time could be invaluable for emergency responders too, right?
Oh, absolutely.
They could position resources and just, get ready to react quickly.
Exactly. I mean, that kind of accuracy can make a huge difference.
And it's not just hurricanes. GraphCast is also great at predicting atmospheric rivers. Think of them as rivers of moisture in the sky that can bring a lot of rain and sometimes, cause devastating floods. So understanding these atmospheric rivers is crucial for managing water resources, getting ready for potential flooding. GraphCast's performance here is really significant. And there's more. It even outperforms traditional methods at forecasting extreme heat and cold, like 5 and 10 days in advance.
Wow.
This is a big deal because knowing about these extreme temperatures well ahead of time can help protect vulnerable people, make sure we have enough food, keep essential services running.
Absolutely. I mean, these are all areas where accurate forecasts are absolutely essential.
Another really cool thing about GraphCast is that it can be retrained with new data. So this means it can adapt to changing weather patterns, which is really important, in a world where climate change is happening.
Right, that adaptability is key.
Yeah.
As our climate changes, we need these forecasting models that can learn and adapt to those changes so we can continue to make accurate predictions.
And the research actually shows that retraining GraphCast with data up to 2020 made it even more accurate in 2021. So it's clear that keeping it updated with the latest information makes a big difference.
It's like updating the software on your phone. You got to keep it current to get the best performance.
So we've covered how GraphCast works, some of its strengths, even a few of its limitations. So what's the big takeaway here?
I think what's fascinating to me is that GraphCast shows us that machine learning has the potential to really change the way we forecast weather. That accuracy, that speed could lead to much better decision-making in so many areas.
It's exciting to think about the possibilities, right?
Yeah.
Like we could have farmers using it to make better decisions about when to plant and harvest, or energy companies planning their grids based on these predicted weather conditions. And imagine what it could mean for disaster relief organizations, right? Getting ready for major events.
The potential benefits are huge.
Yeah.
I mean, it's a whole new chapter in how we understand and predict weather.
But before we get ahead of ourselves, we need to remember that GraphCast still has room for improvement.
One thing it doesn't do yet is provide what we call probabilistic forecasts. This means it doesn't tell us how certain or uncertain it is about its predictions.
So it gives us the most likely scenario, but it doesn't offer that range of possibilities like traditional NWP does.
Right.
It'd be helpful to know not only what that most likely outcome is, but also what the chances are of other scenarios happening, right?
Exactly.
Especially when it comes to these big decisions.
Right. That kind of information helps people weigh the risks and benefits of different options. So before the break, we were talking about how GraphCast is especially good at predicting those extreme weather events.
Yeah.
And we were just starting to touch on how accurate hurricane track prediction, that could really make a difference for people, living in those coastal areas.
Absolutely. Knowing where a hurricane is headed and when it's likely to make landfall, that gives people more time to prepare, to evacuate. I mean, that additional time, it can literally save lives.
Exactly.
The research showed that GraphCast was much better at predicting hurricane tracks than HRES, especially for those forecasts that go out, a few days.
And that's the time frame that's most critical for making decisions about evacuations, getting resources in place.
Right. I can see how this kind of accuracy would be invaluable for emergency responders, Imagine knowing exactly where to pre-position supplies, personnel.
It could significantly improve their ability to respond quickly, effectively.
And it's not just about predicting the path of the hurricane, right? We also need to know how strong it's going to be.
That's right. Intensity is a key factor in determining the potential damage a hurricane can cause. And GraphCast's ability to predict things like wind speed and pressure at different altitudes gives us a much better understanding of the hurricane structure and potential strength.
So this means meteorologists can issue more accurate warnings, right? Giving people a better idea of what to expect, how to stay safe.
It really empowers those individuals and communities to take appropriate action.
We also talked about GraphCast's ability to predict those atmospheric rivers. These things are fascinating to me. It's amazing how much moisture they can transport.
They really are like rivers in the sky. And they can be, both beneficial, bringing much-needed rain, and destructive, causing severe flooding.
Predicting them accurately is really important, right, for a whole range of things, from managing water resources, preventing floods.
Absolutely. And the research showed that GraphCast's predictions of atmospheric rivers were more accurate than HRES, particularly at those longer lead times.
That's really encouraging, especially for places like, the U.S. West Coast, where atmospheric rivers play such a big role in the overall water supply.
Accurate predictions could help them manage those water resources more effectively and be better prepared for those potential floods.
Or even droughts.
Now, shifting gears a bit, we also mentioned GraphCast's skill in forecasting extreme temperatures. Heat waves, cold snaps.
Right.
Those can have a big impact, right, on people's health, agriculture, energy consumption.
Absolutely.
So accurate forecasts are crucial, right, for protecting those vulnerable populations, ensuring food security, keeping essential services running. And GraphCast really shines in this area. The research showed that it outperformed traditional methods in predicting extreme heat and cold events, even 5 to 10 days in advance.
Wow, that kind of advance warning is incredibly valuable.
Imagine cities being able to activate cooling centers, days before a heat wave hits, or hospitals preparing for a surge in those heat-related illnesses.
Farmers could take steps to protect their crops from frost damage. And energy companies could anticipate those spikes in demand, adjust their operations accordingly.
Right. These are just a few examples of how those accurate forecasts can help us mitigate those negative impacts of extreme temperatures.
Another thing we touched on earlier was GraphCast's ability to kind of adapt and learn from new data.
Right.
And this adaptability is what makes it so powerful, especially, in the context of a changing climate.
Absolutely.
As weather patterns shift and evolve, it's essential to have a forecasting model that can keep up, right?
And GraphCast does just that. It can be periodically retrained with the latest weather data to ensure its predictions remain accurate.
It's like giving it a refresher course, so it stays on top of its game.
Exactly.
The research showed that retraining GraphCast with data up to 2020 significantly improved its accuracy in 2021, which really highlights the importance of keeping the model updated.
It's like having a forecasting model that's constantly learning and evolving, getting better and better over time.
Now, we've talked a lot about, the impressive capabilities of GraphCast, but it's important to acknowledge that it still has some limitations, right?
One key area for improvement is the development of those probabilistic forecasts.
Right, we were discussing that before the break. GraphCast currently provides what we call deterministic forecasts, right? It gives you a single, most likely prediction.
Right, which is helpful. But it doesn't capture the inherent uncertainty that comes with predicting the weather, especially over longer periods.
Right. So traditional NWP systems, they try to address this through what's called ensemble forecasting, where they run the model multiple times with slightly different starting conditions.
Right. This creates a range of possible outcomes, allowing us to assess the likelihood of different scenarios.
So, for example, instead of just saying there's a chance of rain tomorrow, it might say there's a 60% chance of rain with a possible range of rainfall amounts.
That kind of information is incredibly valuable for making decisions because it allows us to weigh the risks and benefits of different options.
Think about a farmer deciding whether to plant a particular crop.
A deterministic forecast might say that the conditions look good, but a probabilistic forecast could reveal a significant risk of drought, leading the farmer to choose a more drought-resistant variety instead.
So adding probabilistic forecasts to GraphCast, that would definitely make it even more useful, providing a more complete picture of what the weather might hold.
It would allow us to move beyond just the most likely outcome and consider a range of possibilities, along with those associated uncertainties.
Which is crucial for making those informed decisions, especially, in those situations where the stakes are high, like disaster preparedness or resource management. Now, before we move on to the final part of our deep dive, I want to circle back to a question that came up earlier. We were talking about how GraphCast is trained on data from traditional NWP systems.
Right.
And we were wondering what would happen if these AI-powered models like GraphCast eventually become the main source of weather data.
Yeah.
Could that create a kind of feedback loop where the models are essentially learning from their own predictions?
That's a fascinating question and one that deserves further exploration. It raises some interesting possibilities, but also some potential concerns.
Makes you think about the long-term implications, right, for the accuracy, the reliability of weather forecasts. Could such a feedback loop introduce biases, inaccuracies into the system?
Or could it actually accelerate advancements in forecasting, leading to even more accurate, sophisticated predictions?
It's a complex issue. There's no easy answers.
But it's a testament to the transformative nature of this technology, that it's prompting us to rethink those very foundations of weather forecasting.
We're entering uncharted territory. It's exciting to consider the possibilities, but also important to proceed with caution. Think critically about those implications.
These are questions that will continue to be debated and explored as AI reshapes that world of weather forecasting.
It's a great example of how these technological advancements often come with new challenges, those ethical considerations that we need to address.
Absolutely. And it underscores the importance of having these kinds of conversations, engaging with the broader implications of these powerful technologies.
Well, we've covered a lot of ground in this part of our deep dive. In the final part, we'll shift our focus to the bigger picture. Explore how GraphCast could transform decision-making across those various sectors, from agriculture to energy to transportation and beyond. Stay with us.
Welcome back to the final part of our deep dive into GraphCast. We've been talking about how GraphCast is changing the game in weather forecasting, especially when it comes to, predicting those extreme weather events.
Right. And we've also touched on some of the limitations of GraphCast and some, intriguing questions about the future of weather data itself.
Right. Now, in this final part, I want to kind of zoom out and think about the bigger picture. How could GraphCast actually impact our lives, beyond just knowing whether to grab an umbrella or not?
Well, imagine a world where farmers could plan their entire planting and harvesting schedule
Oh, wow.
around super accurate weather forecasts that go out weeks or even months in advance.
That would be a game changer.
It really would. For agriculture, farmers could optimize their yields, avoid those losses due to bad weather, and ultimately help ensure we have a stable food supply.
Exactly. And it's not just about knowing when to plant, but GraphCast could also provide that detailed information about things like temperature, rainfall, even soil moisture,
Wow.
allowing farmers to make more informed decisions about irrigation and fertilization.
It'd be like having a personalized weather advisor for every farm,
Exactly.
giving them the insights they need to make the best choices for their crops, for their business.
And the benefits extend far beyond agriculture, right? Think about the energy sector. We're increasingly relying on these renewable energy sources like solar and wind power,
Yeah.
which are directly affected by the weather.
Right. Solar panels need sunshine. Wind turbines need wind. So being able to accurately predict those conditions, that could revolutionize how we manage our energy grid.
Absolutely. GraphCast could help energy companies anticipate those periods of peak production, right, for solar and wind power, allowing them to optimize their operations and integrate those sources more seamlessly into the grid.
Yeah, this could be a huge step towards a cleaner, more sustainable energy future, reducing our dependence on fossil fuels.
Absolutely.
Transportation is another area, I think, ripe for transformation. Think about the impact of weather on airlines, shipping companies, even just everyday commuters.
Right. Airlines could use GraphCast to make those better decisions about flight routes, minimizing those delays and disruptions caused by storms or turbulence. Shipping companies could avoid rough seas, optimize their routes for efficiency and safety.
And even for everyday drivers, knowing exactly when and where a storm is going to hit could help them avoid those dangerous conditions and make better travel decisions.
Absolutely.
We often overlook how weather impacts financial markets too, especially when it comes to those commodities like coffee, wheat, corn. Those prices, they can fluctuate wildly based on weather patterns.
Absolutely. Traders and investors could use GraphCast predictions to get ahead of those fluctuations, make more informed decisions, and potentially mitigate their risk.
It seems like the potential applications for GraphCast are incredibly diverse.
Yeah.
I can only imagine, as the technology continues to improve, how many other industries will find ways to use it.
It really speaks to the power of AI, right?
Mm-hmm.
To not only understand, but also predict complex systems like weather,
Right.
opening up this world of possibilities for how we make decisions.
This has been a truly fascinating deep dive.
Yeah.
As we wrap up, though, I think it's important to acknowledge that with any powerful technology, we need to proceed with caution
Right.
and consider the potential downsides. One thing we haven't talked about much is the issue of access. We need to ensure that this valuable weather data generated by GraphCast is available to everyone, not just those who can afford to pay for it.
That's a crucial point. We need to think carefully about how to promote open data sharing, collaboration, so that everyone, including, developing countries and vulnerable communities, can benefit from this technology.
Another consideration is the potential for bias, right? Machine learning models, like GraphCast, they're trained on massive amounts of data. If that data contains biases, those biases can be reflected in the model's predictions.
That's a good reminder that these AI systems, they aren't perfect. We need to be vigilant about identifying and addressing those potential biases to ensure that GraphCast is used fairly, equitably.
Transparency and accountability are also paramount. We need to understand how these models work, what data they're using, what assumptions they're making.
That kind of transparency is essential for building trust in those systems, ensuring that they are used responsibly and ethically.
So as we've seen throughout this deep dive, GraphCast has the potential to revolutionize how we understand and predict weather. But it also raises some really important questions, right?
Yeah.
About data access, bias, transparency, and the future of weather forecasting itself. It's been a great discussion.
Yeah, it has.
This technology, it is incredibly promising, but it's not a magic bullet. We need to be thoughtful and proactive in addressing the potential challenges to ensure that it benefits all of humanity.
Thanks for joining us on this deep dive into the world of GraphCast.
It's been great.
It's a field that's rapidly evolving, and it will be fascinating to see how it shapes the future of weather prediction and its impact on our lives.